Alrighty, so here we're dealing with coordinate geometry, the line. Consider the points P is 1, 2, and Q is 4, 8. Now, we're going to get the slope, the equation of the line between them, the distance between them, their midpoint, the area of a triangle inscribed between P, Q, and the origin, and then we're going to find a point which divides P and Q into the ratio 2, 1. So, we'll start with the slope. Again, everything on this page, it is so important. Everything on this page, you can do with page 18 of your log tables. You need to learn everything on that page. It's okay, like, to think you're going to have this on the day, you're going to have it, you can bring in the log tables with you. That's not really enough. You need to learn these. You need to make sure you know when to use them, how to use them, which questions you're using them. It's handy that you can have them on the day. You can make sure you're writing them down correctly, but you need to be able to look like, okay, slope. I know exactly what formula I'm using, and maybe just use the log tables to verify you wrote it down correctly and whatever. Okay, question one. We're getting the slope. So we have the slope formula in our log tables is m equals y2 minus y1 over x2 minus x1. Now, it is so important as well that at the start of your question, you label which is which. So I'm going to label P as x1 and y1, and I'm going to label Q as x2 and y2. It doesn't matter which one you label which. I could have labeled P as x2, y2, and whatever. But once you label them, you have to stick with it. You have to be consistent in each answer. Because if you get these mixed up, it's the only way you could get these wrong. Other than that, it's filling into the formula. So y2 minus y1 is going to be h minus 2. And x2 minus x1, we're going to have 4 minus 1. So that's going to be 6 over 3, and that's going to be 2. There we go. First question done already. Now, question 2. I think it was to get the equation of the line. Yeah, equation of the line connecting P and Q. So we're going to use our formula y minus y1 is equal to m x minus x1. The other formula, y equals mx plus c, we wouldn't use in this scenario because we don't have the y-intercept. If they gave you the slope of the line and the y-intercept, then it's easy. You can just throw it into that equation. But otherwise, we're dealing with the point and the slope. We're going to be using this one. So x1 and y1, again, I'm going to fill in 1 and 2. So that's going to give me y minus, 2? Yeah, y minus 2 is equal to m, the slope we just got as 2, times x minus 1. Yeah. Simplifying that, we're going to have y minus 2 is equal to 2x minus 2. Then these minus 2's will actually cancel, and we're going to have we could have 2x is equal to y, or we could have y minus 2x is equal to 0. Or like 2x minus y is equal to 0. Either way is fine. They're all the same thing. It's just a matter of what way the question wants you to word it. Then the third one is the distance between P and Q. Again, in your log tables, you don't remember the formula. Look at it. Length of PQ, length of the line and distance between the points is the same thing. So the distance between them is going to be square root of x2 minus x1. So it's going to be 4 minus 1, all squared. Plus, yeah. See, make sure with the formula, look at it. y2 minus y1 is h minus 2. H minus 2, all squared. As well, it doesn't matter which one is x2 and x1, because of this square, even if this is negative, we're still going to get the same number. So it's going to be square root of 4 minus 1 is 3, and 3 squared is 9. No, just 9. And then we're going to have plus h minus 2 is going to be 6, which squared is 36. And that's going to give us the square root of 45. And can we simplify that? That can be simplified to 3 root 5. So there we go. We have the distance between the points, or the length of the line between the points. We have the equation of the line, and we have the slope of the line. The next thing now is going to be the midpoint between them. So, on to part 4. The midpoint between them. Easy way to remember this. Again, it's in your log tables. Easy way to remember this. If I gave you a line like this, and I said, here was 2, and here was 4, and I was like, what's the midpoint between 2 and 4? You tell me it's 3. And all you do there is you do 2 plus 4 divided by 2. You're getting the average of 2 and 4. And that's how you end up with 3. So if you're ever asked to get the midpoint, just think you're getting the average of the x coordinates and the average of the y coordinates. So we're going to have 1 plus 4 over 2. I gotta actually draw this smaller. We have 1 plus 4 divided by 2 for the x-coordinate, and then the average of the y-coordinates will be 2 plus 8 divided by 2. That's going to be 5 over 2, and then 10 divided by 2 is just going to be 5. So that's the midpoint between them. 5 over 2, or 2.5, and 5. Now, the fifth part of this was asking you the area of the triangle inscribed by these points. And that's basically like, okay, this is going to be a rough sketch, but like, imagine we have a graph like this. We have P is here, we have like Q is here. What this is saying is like we're accounting for the origin as well. This formula in the log tables as well is only valid if the origin is included. We're basically getting the area of a triangle like this. That area there. So, look at our log tables. We have the formula. It's going to be a half times the modulus of x1 times y2. x1 is 1 and y2 is 8. So 1 times 8 minus what x2 times y1. So x2 is 4 and y1 is 2. Minus 4 times 2. And this is actually, yeah, this is a funny one. We're going to have a half times 8 minus 8, which is actually 0. So there actually isn't a triangle between these points. We got that the area was 0. That is because the points don't actually look like this. It's a coincidence in this question that these points lie in a line. So there's actually no possible area between them. And that's the reason the area here is 0. But in general, if you're trying to find the area of the triangle with the origin, just look at your log tables, learn that formula off, plug it into that formula, and you'll always get your area. The area being 0 isn't actually wrong in this case. Then we're going to have the final part of this, question 6, is equal to find the point which divides P and Q into the ratio 2:1. Now this one's a tricky one. I'm going to rewrite. Okay, P is 1, 2. I'm going to write this. P equals 1, 2, and then what was Q? Q was 4, 8. 4, 8. And we have the ratio is 2:1. So our A value is going to be 2, and our B value is going to be 1. So we have A here, B here, x1, y1, x2, y2. Now we just fill into the formula. If you forget, look in the page 18 in the log tables, point dividing PQ into ratio A and B. So we're going to have coordinates. We're going to have B times x1. So that's going to just be 1, 1 times 1, plus A times x2, which is going to be 2 times 4, which is 8, all divided by B plus A. That's just going to be 3. So that's our first two coordinates. And then we're going to have B times y1, which is 2, and then A times y2, which is going to be 16, all divided by 3 again, B plus A. So that when we simplify that, we're going to have 9 over 3, comma, 18 divided by 3. Whoop. Why can't I draw the 8? There we go. 18 divided by 3. And when we simplify that, 9 divided by 3 is 3, and 18 divided by 3 is 6. So that's our answer. But if you're ever getting lost with this, it's very helpful to draw the actual, like, the line. So, like, draw something like this, where, here we have P, so we have 1, 2 here, and then over here we have 4, 8. And we're dividing it into the ratio 2:1. So we're going to have, like, for every 2 units across here, we're going to move 1 unit across here. And then you can actually just see our point here is actually just going to be 3, 6. So, like, you could work this out without the formula. Like, see here, we moved 2 units across. Like, if we look at the x value, 1, we moved 2 units across to 3, and then we moved 1 unit across to the left here to get the 3. And then here we moved 2 units across to get the 6. So we actually moved 4 total units. That means because of the ratio here is 1, we'd only be moving 2 the other way, which would give us 6, if that makes sense. Like, there's more than one way to do it. You should always do it this way. You'll never get it wrong this way. But it's always good to, like, draw this sort of thing out so you can kind of visualize it. This next question here, we have a point P, 7, 1, and a line L with equation 2y minus 3x is equal to 4. What is the slope of the line L? There is a formula in the sheet that tells you, like, the slope is equal to negative the number in front of the x, which in this case is minus 3, divided by the number in front of the y, which is 2. So it'd be 3 over 2. A way I like to do it is just rearrange this equation to get it in the form y equals mx plus c. Because then you can just read the value of m. So if we rearrange this, we can get 2y is equal to 3x minus 4. And then when we divide by 2, we can have y is equal to 3 over 2x minus 4. And there's the slope again. So whichever way you prefer, that's just two ways you can do it. I personally would always do it the second way. I feel like getting the equation in the form y equals mx plus c just makes the most sense to me, but you can use whichever one you like. 2. What is the slope of the line perpendicular to L? So remember, say our line L, it looks something like this. The slope of the line perpendicular, so there's a right angle, 90 degrees between them. The slope of the line perpendicular, all we're going to do is we flip the slope of the other line, the blue line we'll say, and we make it a negative. So because the slope of the line L, I'm going to say m1 is equal to 3 over 2. The slope of the line perpendicular, I'll say m2 for the line perpendicular, will be minus 2 over 3. All you have to do, flip the slope and make it negative. Or if it's already negative, make it positive. Just flip the sign. Flip the whole fraction and then flip the sign maybe. And number 3, the distance between the point and the line. Again, this is on page 19 of your log tables. Next page. All you have to do is look at what we're given, look at that formula, and just fill in. So, we're given the line is 2y minus 3x. 2y minus 3x plus 4 is equal to 0. And then we're given the point 71. So, there's going to be x1. I'll actually draw another color so it's not confusing. So this is going to be x1 and y1, and this is going to be a, b, and c. So we just fill into our equation. We go a times x1. Well, we just rewrite this equation, but filling in the x and y values. So we're going to go, in the log tables, it's ax plus by plus c. Basically, just fill in the x1 in for x and the y1 in for y. So we have 2 times 1 minus 3 times 7 plus 4. That's going to be 2 minus 21 plus 4. That's going to be negative 15. That's what goes on the top here. But remember, in the log tables, we take the modulus of this. We'll deal with that in a second. And then our fraction, the denominator is going to be square root of b squared plus a squared. So our total fraction is going to become minus 15 in modulus over the square root of a squared, which is 4, plus b squared, which is 9. Because even though b is negative, because I wrote these differently, technically, it doesn't matter. But like, this would be b and this would be a. The a is the number in front of the x. Well, it doesn't matter. We get the same answer either way. We're going to have the mod minus 15 will just become 15. And then we're going to have the root 4 plus 9 is going to be the root of 13. So 15 divided by root 13. That's the distance between the line and the point. And that's that question done. So the last question here, we want to find the angle between y equals 3x plus 2 and 3y plus x minus 4 is equal to 0. First step here, I'm going to get the slope of both of them. So we have y is equal to 3x plus 2. So immediately m1 is just going to be 3. Then we're going to need the slope of the other line. I'm going to rewrite it in the form 3y is equal to minus x plus 4. Then if we divide by 3, we get y is equal to negative 1 over 3x plus 4 over 3. So that means, 3. That's a terrible 3. 3. That means m2 is going to be negative 1 over 3. Now, we want to find the angle between these lines. We're just going to use the log tables. We have tan of theta is equal to plus or minus m1 minus m2. So 3 minus negative 1 over 3 divided by 1 plus m1 m2. So it's going to be, not m1. We're going to put 3 and then times minus 1 over 3. Wow. That's going to be division by 0. Okay, this is going to be a special case. I'm going to show you anyway. So we're going to have plus or minus 3 minus 1 over root 3 is going to just be 3 plus 1 over 3. So that's going to be the same as 10 over 3. All divided by, we're going to have 1 minus 1. Because 3 times negative 1 over 3 is minus 1. Notice, we're going to have division by 0, which we can't have. So that means we're going to have tan of theta is equal to something divided by 0. And if we're dividing by 0, that means that this angle here has to be 90 degrees, which, it's tricky, but like if you know the graph of tan from another page in this file, the graph of tan looks something like this. It goes off to infinity at pi over 2 or 90 degrees. That's what's happening here. Because we're dividing by 0, this thing is actually shooting off to infinity. Because if you divide by 0, it's like you're dividing by something very small. So the thing on top is going to get really, really big. This is a funny scenario, but this angle will just be 90 degrees or pi over 2. And that's purely because we're dividing by 0. But in general, if you fill into this equation, if you get the slope of the first line and the slope of the second line and you just fill in, you're going to get the right answer. But in this case, yeah, it's 90 degrees.